Okay, it says we're recording 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Only 11 people here today? All right. So, and Ivan, why are we looking at your ceiling? Are you really there? Are you just trying to, oh, there I see part of your head. Okay.
I am. I'm just
So,
getting something. Getting something to eat in my kitchen.
okay. Okay, all right. As long as you're paying close attention.
Oh no, yeah.
I don't want you just being like, oh, I'm on camera, but I'm off camera.
No.
Okay, so, all right. So today I am a little bit worried. This is going to be a very long lecture. We may not cover the whole thing. So your quiz will be whatever we cover today, but we are going to talk about vectors now. Let's see, we got 9 people that are kind of on camera. Brian's not really on camera. 8 people, if we include Ivan popping in and out. How many of you are planning to take physics by raise of hands? And if you're not on camera, say aye. Okay. Oh, Brian raised his hand on there. That's pretty good. So most of you are taking physics, okay? Nicole, what's wrong with you?
I already took it.
Oh, you already took it.
I took physics 1 and 2.
Oh, but that was it calculus based or was it not?
It wasn't calculus based, no.
Oh, okay. How many of you are maybe I should have asked that question again. How many of you are taking calculus based physics, planning on taking it? Okay. So I just want to warn you, this section is going to be extremely, extremely helpful for that. And not only, by the way, Nicole, I have to tell you something. When I was in college, I thought, okay, they have calculus-based physics and they have not calculus-based physics. And I made the mistaken belief that not calculus-based physics would be easier, and it is not easier at all.
That's what they always said teaching us, yeah.
Say it again?
That's what the teacher said. He's like, it'd be so much easier if I was teaching you calculus-based.
Oh, so, I know.
Yeah.
It's horrible. Calculus makes it so much easier. So what I'm going to tell you about here is vectors. You're going to use vectors in physics. And not only that, if you guys ever want to take a nasty math class, there's a class that I took called vector analysis, where all you talk about is vectors, vectors, vectors. So this, you may look at this and go, well, I don't know, this is kind of weird. But yeah, you just can go crazy on vectors. So anyway, so we're going to talk about scalar quantities are real numbers with a unit. So 25 meters per second, 30 square feet. Those would be examples of scalar quantities. A vector quantity has a magnitude and a direction, okay? So basically you can think of a vector as just an arrow. You have an initial point and you have a terminal point, okay? And these can be really helpful, especially in finding forces. So your initial point is the tail of the vector or the start of the vector, and the terminal point is the head or the arrow. It's the end of your vector, okay? So these can be extremely helpful, especially in physics, okay? So if I have, so a lot of times we will describe it as a vector, so a letter with a little arrow on top of it or a ray on top of it. So 2v, or 2 times so the v is going to indicate that this is a vector, and 2 is going to be a scalar. Put number 2 there. That's going to be a scalar multiplication. So when you take a scalar and you multiply it by a vector, we're going to call that scalar multiplication. Just so you know, we'll also do vector multiplication in a few minutes here. And so scalar multiplication multiplies by the change of magnitude, but it does not change the direction. So basically, if this is your vector v, if you had 2v, it would be a vector that was twice as long as this current vector, okay? So we can also talk about the resultant vector is the sum of 2 vectors, and they can be added graphically. So if I have a vector u here, and I have a vector v here, if you do u plus v, this would be your resultant vector. And so, so that's kind of easy to understand visually. Now, if we wanted to do v minus u, what you could do, because subtraction is a little bit hard, is you could say, I'm going to take v plus a negative u, okay? So the idea here is, this is the same picture here, but if this is u and this is v, and I want to take v minus u, all I will do is take u, I will make it in the opposite direction, so that's a minus u, and then you can add them, v plus minus u, you're going to get this resultant vector. Okay, does that make sense? See that? Okay, I got some head nods. Good. Okay. So equivalent vectors have the same magnitude and direction. Okay. So consider the vector with an initial point at 2, -1, so that would be right here, with a terminal point at B, which is at -3, 4, okay? So that's this top vector here. An equivalent vector would be -5, 5, where you start at the origin and you go to -5, 5. You can see that these have the same magnitude and the same direction. All I've done is I shifted the initial point, instead of being at 2, -1, is now at the origin, okay? So these two vectors would be equivalent vectors. One is just shifted to the origin. Another example of equivalent vectors, if I started, I know that's hard to see, x1, x2, excuse me, x1, y1, and x2, y2, this vector would be an equivalent vector with that. So you've got the same magnitude and the same direction, okay? All right, so what we can do, an equivalent vector from the origin would have a terminal point at -5, 5. And so you can see here, if I take -3, -3 minus 2, that gives me -5, and 4 minus -1 is +5. So A is just, you subtract the x's, B is you subtract the y's. These are called the components of a vector, okay? So let's start picking on some people here. I think Texas got out of the case yesterday, so we'll start with Texas. So if I find the components of vector AB with an initial point, A is at 2, -1, and B is at -2, 6. And you want to find an equivalent vector with the start at the origin. So how would you do that?
Basically, like you said, like you do subtract, this would be -2 minus 2, and then 6 minus a -1, which would be yeah.
Okay, perfect. So -2 minus 2 is?
-4.
-4, and 6 minus -1?
That'd be 7.
7. Okay. Now, did you look and see the answer was right there?
Oh, what do you know?
I'm glad you didn't see that. Okay. All right, so I got away with that. Say that again?
I wish
I wasn't
class
even looking.
Yeah.
Oh, sorry.
All right, now, one of the other things that we will do here is, instead of using parentheses as we do with a point, with a vector, we will put those in those greater than, less than signs. Okay, so you can think of this kind of like an ordered pair, but when we're using vectors, rather than putting them in parentheses, we'll use the greater than and less than sign. Okay, does that make sense? All right, so exactly right what you did there. Okay, so let's talk about the definitions of fundamental vector operations. If vector V is AB and vector W is CD, they're two vectors, and K is a real number, Okay. Now it's hard for me to draw this, but this looks kind of like two absolute values next to each other. So we're gonna refer to this as the magnitude of v. So the magnitude of vector v is going to be just the square root of a squared plus b squared. So you can kind of think of that as just the Pythagorean theorem. Okay. If you're adding two vectors, you're adding vector v and w. All you're going to do is you're going to add the x coordinates a and c. Excuse me. Oh. Actually, I think I drew that wrong. A plus C and B plus D. I did do that wrong. Okay. Fix my notes as we do that. So you're going to add the x coordinates essentially. You can think of these as the x coordinates, and you can think of these as the y coordinates. Okay. So vector V plus vector W equals A plus C and B plus D. And if K is a scalar, okay, so that's just a real number. K times the vector v is just k times a, comma, k times b. Okay. We will also define the zero vector. That's just 0, 0. The additive inverse vector of vector v, a, comma, b is given by negative v. And you're just going to basically multiply it by the scalar -1. Okay.
I have a question.
Okay, go ahead.
So when you put on number 3 where it says KV, are you like distributing the K in the order pair?
Yes. Yeah.
All? Okay.
Think of that exactly like as distributing it. Yes, that's exactly right.
Okay.
Okay. All right. So given vector v is -2, 3, and vector w is 4, -1, find the magnitude of w. Okay. So let's see here. Maybe I'll erase that there. So since we picked on Texas, we'll start at the bottom again. Tate, can you find the magnitude of w?
So do I just take the square root of 4 squared plus 1 squared?
Yeah, because you can ignore the
Sorry, that
negative.
was a
'cause it's gonna go
question.
away.
But I was unsure about it. So that's
When you square it, the negative goes away. So yeah, I won't worry about it.
okay.
Technically, just if you want to be super accurate, it's -1 squared. But yes.
Okay.
Okay. So 4 squared is
16 plus 1 is 17.
This is
So the square root is 17.
Perfect. Okay. And that is what I had there. Okay. All right. Now let's find.
So we didn't need to worry about the other ordered pair, the -2, 3.
Well, I only asked.
Oh,
if
for
it
A.
was
Okay.
But we'll use that now in this one. Okay. So since that was Tate, Nicole, it's your turn. Can you tell me what vector v plus vector w equals?
Yeah, so it would be -2 plus 4. And then the other one would be 3 plus -1.
Okay.
So then that would be 2, 2. 2,2.
Okay, well done. Okay. So just remember, since we're dealing with vectors, we're going to put those in the greater than, less than signs there. Okay. Perfect. All right. So now, can you tell me? I'm trying to get rid of these. What would be
6, 9.
-3v?
6, 9.
Oh, you're a cheater.
I'm kidding.
That was too easy, right? You're actually kind of liking these vectors right now, right?
Yeah.
I was
but
going to
like
pick
I'm
on
gonna
you next,
hate-
Ivan. I
feel
guess
like
you knew.
I feel like I'm gonna hate it in a little bit.
Yeah, you will. But I'm trying to be nice to you at the beginning here. So these aren't too bad. You take these questions. Jackson, can you do 2v minus 3w?
Yeah, I can do that.
Okay.
So 2v would be, you want me to do every step, or can I just skip?
Yeah, you can simplify. I think we got this down.
So it'd be -4, 6, and 3w would be 12, 3. And now to subtract those, we do -4 minus 12, which is -16. And 6 minus 3, which is 3.
Isn't it -3? So W is 4, -1.
So yeah, that's correct. So you gotta be careful with your signs there, because we left this negative outside, and you did +3 times 4, which is +12. But then you've got +3 times -1 is -3. So therefore, this is no longer 3. It's what?
It's -3.
It's 9.
Well, -3 times.
Okay. 6 minus -3 is 9.
Yeah.
Okay. All right. Well done. Okay. So yeah, just be careful on the signs there. Okay. All right. Some new terms we're going to learn. We're going to talk about the unit vector. Okay. The unit vector. Now this is going to become key not only in this section but in the next section as well. Unit vector is a vector with a magnitude of 1. So an example would be vector v, that is 3/5, -4/5, is a unit vector because when you find the magnitude of v, 3/5 squared plus 4/5 squared is going to be 1. So 3 squared is 9, and 16 is 25 over 25, so that would be just 1. Does that make sense? All right, so given any non-zero vector v, we can find the unit vector by dividing by the magnitude, which is, of v, which is the magnitude of v. Okay, so that was Jackson. Graham, can you find the unit vector for vector v, which is 4, 2?
I think I'm a little bit lost.
Okay. So, okay, let's break it down. Can you tell me the magnitude of vector v? Do you want to look back and see how we did that earlier?
Yeah, I'm not sure.
Right here, this is what we did with vector w.
Oh, okay. So you would do, because it's -4 2, so -4 squared.
So the
plus
square
2
root
squared.
of -4 squared
plus 2 squared.
2 squared. I don't know why I do that. I do that all the time. Okay, so -4, so this would be the square root. -4 squared is
16.
16 plus 2 squared,
4. So
4.
20 squared 20.
So equals the square root of 20. Okay, so now what we want to turn this into is a unit. So find the unit vector for this. So all you have to do is multiply or divide by the magnitude.
So divide each point or each term by this?
Yeah.
Okay.
Instead of calling these points, you can think of them as points because essentially, if you start at the origin, they are points. But if you don't start at the origin, they're not points. And so that's why
Right.
we put them in these greater than, less than signs.
That makes sense. So it would be -4 over the square root of 20, comma 2 over the square root of 20, right? And then we'd simplify it from there.
Yeah, you could do that. So it's -4. Oh, gosh, I cannot type today. There we go. -4 over the square root of 20, comma 2 over the square root of 20. Okay. And I'm supposed to put these in brackets, sorry. Or whatever these are. Greater than, less than. So, well done. That's exactly right. Okay. So, you could also write that instead of the square root of 20, that's 2 square roots of 5. So your unit vector, a lot of times we'll use a u instead of v, but so -4 over 2 square roots of 5, 1 over 2 square roots of 5, or if you rationalize the denominator, that also becomes -2 square roots of 5 over 5 and the square root of 5 over 5. Okay.
So on our tests and like homework and stuff, will you want us to rationalize the denominator and simplify it as best we can?
Generally, yes.
Okay.
So, all right. Okay, so I got another definition for you guys. We're going to define, this is a special vector I, as the unit vector 1, 0, and we're going to find j as the unit vector 0, 1. So all vectors can be written in terms of these two unit vectors I and j, okay? And so an example is 3, 4 could be written as 3i plus 4j. Okay, so this is probably a fairly easy one here. Given vector v is 3i minus 4j and vector w is 5i minus 3j, find 3v minus 2w. And so it must be Chris Hardwick's turn. Hopefully you have good internet today, Chris. Can you help me with that?
Can you hear me?
Yes.
Okay, good. So
Sounds a lot better today.
yeah, 3i minus 4j, w 5 minus 3j, 5 3v plus 2w. Okay, so
You will want to speak up though. I know you're just talking through the problem.
Yeah, sorry. All right, so you just multiply the vector v, which is 3i times 3, so that'd be
Just 3i times 3 would be
9i
9i
minus 12j.
minus 12j
2
minus, we'll put this in parentheses just to keep them separate.
Okay, and then so 2 times 4j is 8j. Oh, sorry, I'm looking at the wrong thing. 2 times 5i is 10i minus 6j.
6j. And of course, I should have little vector signs over those to write them, okay? All right, well done. And so 9i minus 10i is?
That's negative 1i, or negative i. And then negative 12j.
I don't want uppercase. Minus. So negative 12j minus 6j.
Is, let's see, that's negative 6j.
Perfect. Okay. Well done. Okay. You like these problems, right? These aren't too bad. These will be good for your quiz tomorrow. Okay. All right. So the components of vector v can be written in terms of magnitude and direction. So the magnitude of v, as we said, is just a1 squared plus a2 squared. And we can use trig to see that the cosine of theta is going to be a over the magnitude of v, and the sine of theta is a2 over the magnitude of v. So then if v is a non-zero vector that equals a1, a2, then a1 is going to be the magnitude times the cosine of theta, and a2 is going to be the magnitude of v times the sine of theta, where theta is the angle between the positive x-axis and vector v. So these are what's known as the horizontal and vertical components. Okay. So find the horizontal and vertical components of vector v with a magnitude of 10 meters and a direction angle of 228. Okay. So in order to do that, we're just going to pull in here. A1 is going to be your magnitude. We know your magnitude is 10 meters times the cosine of theta. And so 10 times the cosine of 228 is going to be negative 6.7. A2 is going to be your magnitude, which we know is 10 meters because we gave it to us, times the sine of theta. So 10 times the sine of 228 is negative 7.4. And so therefore, if the vertical components would be negative 6.7i minus 7.4j. So does that make sense? Graham's like, sort of, kind of. All right. Too bad though. These would be good quiz questions, right? Okay, let's do another one here. So I've got an airplane
I've got
traveling.
a question.
Okay, go ahead.
Sorry.
About this one?
It took me a while I was unmuted it, but yeah, about that one. What is the I and J? Like, why do we include that?
These are the unit vectors. So remember your unit vector is just, think of, so this is basically the x component, and this is basically the y component.
Okay, so as long as we're finding unit vectors, it's always going to be I and J included in the equation.
So when we write these into terms of unit vectors, 6.7 in the x direction minus 7.4 in the y direction.
Okay, that makes sense.
That's a good way to think about it. Okay. Yeah, we're just introducing you to some new terminology here. All right. Well, I'm doing this for Ivan because I think Ivan loves story problems, right? Okay. Airplane is traveling at an airspeed of 320 miles per hour. Has
You
a
lost me
heading
at
of
airplane.
That's a heading of 62 degrees. Okay, so you can see here. So the airplane has a heading of 320, a heading of 62 degrees. So we're measuring that from the y-axis because we're doing headings. Okay. Has a wind speed of 42 miles per hour, is blowing at a heading of 125. Okay, so your airplane's going this way, your wind's going this way. So you can represent these as vectors, and because the wind is pushing the airplane, even though the airplane has a heading of here, he's really being blown off course and he's going here, AC. Okay. So it says find the ground speed and the course of the airplane. Okay. Because the wind is pushing it along this path. Okay. So the idea here is we can treat these as vectors. Okay. So AC here, this is where it's really going. This is where it thinks it's going. And this is where the wind is pushing it. Okay. So you can think of AC as AB plus AD. Okay. So the way to think about this is AB here is going to equal 320 because that's the magnitude. That's how fast the airplane is moving. Okay. So that's your magnitude times the cosine of 28 degrees. We're measuring cosine from the x-axis rather than from the y-axis. Okay. So the cosine, and then we're going to use the unit vector I plus the sine of 28 times the unit vector of j. Okay. Now, so that's going to be your vector AB right here. Okay. Your vector AD, this is your wind, okay? So you've got a magnitude of 42-mile-an-hour wind, okay? You've got a cosine, okay? So it's measuring 125 degrees from the y-axis, but from the x-axis, that's a negative 35-degree angle, okay? Because this, 125 minus 90 is negative 35, okay? So you get the cosine of a negative 35-degree angle times our unit vector I plus the sine of negative 35-degree angle times our unit vector of j, okay? So that's going to be your vector AD, okay? So what's nice about this is you can take AB plus AD to get AC, which is where the plane's really going. So now we just take, this is going to be AB plus AD. And now that we've got these into components, we'll just plug this into our calculator. So 320 times the cosine of 28 works out to be 282.5 I. And then 320 times the sine of 28 degrees is going to be 150J. We're going to add that to 42 times the cosine of negative 35 degrees. That equals 34.4 I. And the sine of negative 35 degrees times J equals 24.1 J. So now I can add 282.5 plus 34.41 gives me 316.1 I. And then my 150J plus my 24.1J equals 120. Oh, actually, that's got to be a minus. I think this is a negative because that's 150 minus 34 is 126 I. Excuse me, J. 126.1 J. Okay. So does that make sense? Yeah, it's got to be a negative here because the sign of a negative number would be a negative. Okay. So AC is going, so we've got, so this is the AC in terms of the unit vectors I and J. So let me stop there and ask if anyone has any questions. Okay, makes sense? Okay, so AC is the course of the plane. Your ground speed is just going to be the magnitude of AC, okay? So if I take the magnitude of this new vector AC, that's just going to be the square root of 316.9 squared plus 126.1 squared, and that works out to be approximately 340 miles per hour, okay? So now, the heading, because remember we're measuring heading from the y-axis, not from the x-axis, that's just going to be 90 minus theta, and this here is your angle theta here, okay? And so that's just going to be the inverse tangent of basically your x and your y component. So this is your y component, this is your x component. So that's going to be the inverse tangent of 126.1 over 316.9. And so that's going to be a heading of, actually, yeah, 90 minus that is going to be 68 degrees. So this angle here, alpha, is 68 degrees. So essentially what we're saying here, the wind is blowing you 6 degrees off course because the plane was heading at 62, now we're going at 68 because of the wind. Okay? Does that make sense?
I have a quick
I just
question.
have
Questions, go ahead.
Okay, so I understand why it's the inverse because we're looking for degrees, but why is it the inverse of the tangent?
Okay, so think of it this way. This is you've got your x component here, you got your y component here. This angle theta is just y over x.
Ah, okay, that makes sense.
Yeah. Okay. Any other questions? Okay. All right, we're almost halfway through here. Okay, so let's do another one. Now, let me just warn you guys that are, I guess, not Nicole. Nicole, you probably had to do something like this, didn't you? But it was a lot harder. Did you have to do this in physics? All right.
Mhm.
So this is a very common physics problem, and you will do 100 of these probably when you take physics. Car in the photo weighs 2,855 pounds. Find the magnitude of force needed to keep the car from rolling down the ramp, and find it to the nearest pound. Okay. All right. So here we are. Essentially, you've got the car, the weight. So you can think of W as the weight of the car, and we know that that's going to be 2,855 degrees. Okay. Now, one way to think of it is you've got two different forces. So you can think of W as the resultant force from these two force components here. So force 1 is going to be the same angle as your ramp. Okay. Force 2 is going to be the perpendicular force here. Okay. So we can turn W into a right triangle here. Okay. And of course, force 2 is also going to be a right angle with the ramp here. Okay. So so the idea here is, we're trying to keep the car from rolling down the ramp. So if this is the force of the weight here, then minus F1 is going to be the force needed to keep the car from rolling. Okay. All right. So the triangle formed by the weight W, the force 1, and force 2 is a right triangle in which the sine of 15 degrees equals the magnitude of force 1 over the magnitude of the weight. Okay, so you can see here, basically when you're doing these, you've got a bunch of similar triangles. You've got a 15-degree ramp here. Okay, that 15-degree ramp, this is going to be the same similar triangle here as this 15 degrees between the weight of the car going straight down and the perpendicular force 2. Okay, so this angle here is always going to equal the same angle right here. Okay, and so when we're looking at this graphically, you've got your force 1 here divided by the weight of the car. That's going to be the opposite. This is the opposite over the hypotenuse. So W is your hypotenuse. Okay, so that's just going to be Y over R, or Y over H, I guess, for the hypotenuse or whatever. So does that make sense? I know, especially the first time you're learning these, it's hard to keep track of all these, but these are just similar triangles. So does anybody have any question on how I got the sine of 15 is force 1, the magnitude of force 1 divided by the weight?
So that it's just like 90 minus whatever that angle is, right?
Right.
And is that how it will always be if we have another problem like this?
So when you have another problem like this,
Okay.
whatever the angle of the ramp is here is going to be the same angle right here. These are just similar triangles.
And that, okay, the 15 degrees is between F2 and the ramp the car is on. Or, well, between the weight. Yeah.
Yeah.
See that? Okay.
Okay.
Okay, thank you.
All right. Okay, so okay, so we've got that there. Okay, so the magnitude of force 1 needed in order to keep the car from rolling down the ramp is going to be simply the weight of the car times the sine of 15 degrees. And so that's going to be 739 pounds of force. So you would need 739 pounds of force to keep this car from rolling down the hill. Okay, basically all I've done is I've taken this equation here and I've solved for the numerator here, F1. So if I multiply both sides times the magnitude, and the magnitude is just the weight is 2855. So I've got the weight here times the sine of 15 degrees equals the force required to keep the car from rolling down the ramp. Okay, does that make sense? Now, I promise you, when you take physics, you're going to do a boatload of cars rolling down the ramp, and you'll probably do a fair number in this class. So when you get to physics, you'll be like, ah, I got it. This is easy. Okay? Now, part B says, find the magnitude of force that the car exerts on the ramp. Okay? And so that's going to be F2. Okay? F2 is the force that the car exerts on the ramp. Okay, so the magnitude of the force says I just need to find the magnitude of F2. So the idea here is, once again, as I'm looking here, now I'm going to use the cosine because I've got the adjacent over the hypotenuse, essentially. Okay, and so the cosine of 15 degrees equals F2 over your weight. If I solve that for F2 and multiply both sides times the magnitude of the weight, I'm going to get the magnitude of F2 equals the weight of the car times the cosine of 15 degrees, which works out to be 2758 pounds of force. Now, the interesting thing here, well, see, that's basically almost, it's not quite equal to the whole weight of the car because some of that's being displaced there. But yeah, so 2758 pounds of force. Okay. Any questions on that?
I do have one question.
Okay, go ahead.
How is the force the car exerted on the ramp useful in a practical application? I'm just curious.
Well, if you're building the ramp, you need to make sure that it will support the weight of the car.
Oh, gotcha.
So essentially, I mean, probably the easiest thing to be, well, if it weighs that, it's got to hold at least that. Although you could get away, it's not the entire weight. I mean, what's the difference there?
So, like, if you were to put a scale,
It's about 100-pound difference.
If you were to put a scale, somewhere on the ramp to find the 2,758 pounds of force, how would you find that?
That's taking into account whatever's holding the car back isn't also putting weight on the ramp.
Right.
Okay.
So if you're
gotcha.
standing in front of the car pushing on it, you're also
Right.
putting the force that you're pushing on the car onto the ramp,
Right.
plus your own weight.
Oh, okay,
Right.
gotcha.
Yeah.
Okay.
And I would not want to be, I mean, 739 pounds of force, man, that's a lot of weight. So, by the way, I have to tell you, just as a quick digression here, there's a TV or a thing on Netflix called, what's it called? No, it's about veganism. There's a guy that is a vegan and his mother died being crushed by a car. And so he wanted to be able to be strong enough to take a car like this, and he flipped it over with just, he had no help. He flipped an entire car over. It's unbelievable. Anyway, I showed my son that, and he's like, oh, so anyway, vegans are strong. All right. Okay, so are we good there? Does anybody have any questions about this? Because you'll have homework problems like this.
So can you just go over real quick? I think I'm a little bit confused about the magnitude. So is the magnitude like what would be the equivalent of like the inertia of a certain line when you're talking about vectors? So it's like the force behind a vector that you're trying to figure out?
Yeah. You can think of it as force.
Okay. All right. Thank you.
Okay. All right. So we're going to move on to a new topic here, and we're going to talk about the dot product. Okay. Now we talked about scalar multiplication before. We're going to talk about the dot product, which is a way to multiply two vectors together. It always gives a real number. Okay. So basically, a dot product is you're going to turn two vectors into a real number. Okay. So given a vector v, which is AB, and a vector w, which is CD, the dot product of v and w is given by AC plus BD. So we're just multiplying the x values together, and we're multiplying the y values together, and we are adding them together. Okay? So this isn't too bad, hopefully. Can you find the dot product? Where did I stop? I think it's Cassie's turn. Cassie, can you find the dot product for v dot w? You there, Cassie? You're on mute.
Yeah, I don't have a very stable connection today, so I don't know if I'm gonna
Okay, sound pretty good.
But so it'd be negative 18 plus negative 8.
Okay, equals
Negative 26.
negative 26. Okay, you want 10 of these for tomorrow's quiz?
Yes.
Okay. All right, that was pretty easy. All right, perfect. You did it exactly right. Okay, all right. So now let's talk about the properties of the dot product. So the dot product has the following properties. Let's talk about vectors u, v, and w, and we're going to use the letter A as a scalar. Okay. So v dot w equals w dot v, so it's commutative. Okay. If I do u dot v plus w, that equals u dot v plus u dot w. So you can think of that as the distributive property. So that works nicely. So A is a real number times vector u dot v equals A dot u dot v. Okay, so that's interesting because you only multiply it by one of the vectors. But it is commutative as well. You could also do u dot av. So you could multiply the a by either one, but don't multiply it by both. Okay, so that's a little bit different. Just pick the a times one of the vectors and then do the dot product. Okay. V dot v is basically just the magnitude of v squared. Okay. If we talk about the zero vector, 0 dot v is just plain old 0, so that makes a lot of sense. If we're talking about the unit vector I dot I equals j dot j, which equals 1, so that makes sense. If you've got the unit vector in the x direction and the unit vector in the y direction, you're just going to get the 1, which is basically the magnitude. Okay. Now I dot j and j dot I, if you equals j dot I, and in both cases, the dot product is 0. Okay. Now, this is going to be very useful because if you think of I as the unit vector in the x direction and j in the unit vector in the y direction, okay, these are perpendicular lines. Okay, so this is going to be useful. If you get a dot product and it equals 0, you now know that those two vectors are perpendicular. Okay, so 7 is going to be very useful for determining if two vectors are perpendicular. Okay, we've also got an alternative formula for the dot product. If v and w are two non-zero vectors and alpha is the smallest non-negative angle between v and w, then v dot w equals the magnitude of v times the magnitude of w times the cosine of the angle in between them. Okay, so that's an alternative formula. Okay, we can solve this formula here to just for the cosine of alpha, and so if you want to find the angle alpha in between them, if V and W are two non-zero vectors and A is the smallest non-negative angle between V and W, the cosine of alpha equals V dot W over the magnitude of V times the magnitude of W. And of course, the angle alpha is the inverse cosine of V dot W over the magnitude of V times the magnitude of W. So this is going to be a very useful formula for finding the angle between two vectors V and W. So any questions on that?
Do we need to memorize all this?
Yeah, unfortunately.
Goodness.
And it's not this is the math department telling you that, not me being a jerk.
Yeah.
So they're going to expect you to know that. Okay. All right. So let's just do this. So find the angle between vector V equals 3i minus 2j and vector, I need a space there, vector W, which is negative I plus 5j, okay? So we've got these drawn here. Basically, think of this as the point 3, negative 2. And that looks like 2, negative 3, though. Oh, it is. I drew that wrong. That should be 2i minus 3j. Okay, now it matches my graph. Okay, 2i minus 3j. And W, let's make sure this one's right, negative I and 5j. Okay, that one's correct. Okay. All right, so find the angle between 2i minus 3j and negative I plus 5j. Okay, so we can use that formula we just learned here. So the cosine of alpha is going to equal the dot product between V and W over the magnitude of V times the magnitude of W. Okay, so the dot product is just going to be 2 times negative 1 is negative 2. Negative 3 times 5 is negative 15. Okay. Now the magnitude of this is 2 squared plus 3 squared. The magnitude of this is 1 squared plus 5 squared. I'm ignoring the negatives because they're going to fall out when you square everything. So essentially this gives me the square root of negative 17. I need to fix this. Negative 17 over the square root of 3. Let me make sure that number is right. Oh my, looks like I have a few problems with my notes. What did I say there? The square root of 13 times the square root of 26. 12 times 26, is that what I said? Yeah. Times 26 is 312. Ah.
That's 13 times 26, not 12 times 26.
Well, thank you. I was like, okay, thank you. Can't read my own writing there. 330. Okay, so I've got negative. So then I've got negative 2 minus 15 is negative 17 over 338. So that's going to be this divided by that.
Well, it's the square root of 338, remember?
Thank you. There we go. So negative 0.92. So if I do the arc cosine of that, that's going to give me radians equals that times 180 divided by pi. Oh, so that's okay. So anyway, that was right, but I'm glad I fixed my mistake there. So your alpha, your angle between those two is going to be 157.6 degrees. Okay. Glad I checked my work on that one. All right, I know we're about running out of here. Do I want to save this for next time? Yeah, this is related. Okay. Because I know we've only got about 5 minutes left. Okay, so let alpha equal the angle formed by two vectors v and w. The projection is the right angle formed from the terminal point, okay? So if I've got vector v and vector w, the projection of w onto v is going to be this length right here, okay? And so, so if v and w are two non-zero vectors and alpha is the angle between v and w, then the scalar of projection of v onto w is given by the projection of v onto w is the magnitude of v times the cosine of alpha, okay? So we've kind of got this, these graphs here, okay? So this is the projection of v onto w, so that's going to be this entire length here. And this is the projection of v onto w here. So remember, the dot product of v dot w equals the magnitude of v times the magnitude of w times the cosine of alpha. So we can solve for the magnitude of v cosine alpha to get, so the magnitude of v cosine alpha equals v dot w over the magnitude of w. And this can be plugged in to get the projection formula. Projected v onto w equals v dot w over the magnitude of w. So on acute angles, the projection is positive. On obtuse angles, the projection is negative, and that's illustrated by this. So this would be your obtuse angle here. This would be your acute angle here. Okay.
So what is projection? Like, what does that mean? How does that
So
translate
graphically,
into?
you can see this here. The projection of v onto w is going to be this length here that forms a right triangle. So essentially, it's so w is a lot smaller, but the projection of v on w is going to be this length here that forms a right triangle.
Okay.
And the same thing here, you're also going to form a right triangle. If your angle is obtuse, the projection of v onto w is going to be this length of this right triangle here. So even though w is not really part of this triangle, we use it to find the projection onto here.
How are projections used?
You're trying, basically these, you can think of these as force once again.
Okay.
All right, I know we're about out of time. I think, well, yeah, I kind of mentioned this before, so I'm going to finish off on this. Parallel and perpendicular vectors, okay? So you can see two vectors are parallel when the angle between them is either 0 or 180 degrees. So when an angle is 0, the vectors point in the same direction. And when the angle is 180 degrees, then the vectors point in opposite directions, okay? And two vectors are perpendicular or orthogonal when the angle is 90 degrees. And as I mentioned earlier, this happens when your dot product is 0. So two non-zero vectors v and w are orthogonal or right angles, that's what that means, if and only if the dot product is 0. And I know I'm out of time, so we're going to save all of the work for Thursday. We don't have much left in this section. Oh, actually, gosh, we're so close. I'm going to save work because I think I've overloaded your brains already. We're making up for the last 2 days where we got out a little bit early. I will go ahead. We'll talk about. I'll post these notes, but I'm going to save work for next class period because I don't want to rush through that. That can be a little bit confusing. So, do you guys have any questions for me? Okay. So as far as homework, it's almost all of 4.2. The work problems, I think I'm pretty sure at the end. Oh, I'm looking at the wrong section here. So almost all of 4.2. Just don't worry about the work problems. And so I will post, and I'm sure we'll probably finish. I think we're moving on to chapter 5, aren't we? Yeah. So we're already done with chapter 4. It was just the 3 sections. So homework is everything except for the work problems in 4.3. Your quiz will basically be everything but the work problems that we've done. And I'll post this video. I had a lot of problems posting it yesterday, but it seems like you guys don't watch these very often anyway. So
I
all right.
watched them.
Any questions that you guys have for me?
I watch them actually.
Okay. Because I think out of the last 10 videos, 6 of them have not been watched.
Yeah, I watched them through Microsoft Teams. So
Oh, okay.
yeah,
Oh, yeah. Instead of on YouTube.
yeah.
Yeah, I was talking about YouTube. I don't know if you guys watch them on Teams, but all right. Well, I'll let you guys go. Brian finds them useful. That's good. So see you all tomorrow and stick around for Texas Study Group if you want.